Hello, everyone. Welcome to the Ionic YouTube channel. My name is Logan Braid. I'm developer advocate here with Ionic. And today I'm joined by Dallas. Dallas, if you could introduce yourself.
Hey, Logan. I'm super excited to be here. Hey, everybody. My name is Dallas James. I am the product manager for Capacitor here at Ionic.
So, Dallas, what are we going to be talking about today?
Yeah, I'm really excited. So over the last couple of weeks, I had this idea for an application, which I think we all kind of get those. And I realized I'm probably paying too much for ChatGPT. It's great. I love it. I don't think I use it for $20 a month, but I'm a developer and I know how to use APIs. So I thought it would be really fun to take advantage of their API and build a ChatGPT clone for myself using Capacitor so that I could ideally save a little bit of money every month.
Oh, there you go. I know. Well, ChatGPT, they charge too much.
I know, right?
We're struggling developers. We have to pay the bill somehow.
Yeah, so I thought it'd be fun. Let's build a ChatGPT clone, and we could take advantage of Capacitor, and it's a good exercise to stretch your legs and just have fun building an application.
Yeah. So maybe why don't you tell us about some of the tech that you use to build this?
Yeah, absolutely. So. For me, there's all sorts of tech choices that you can make. I really just kind of went with my favorite tech to use right now. So obviously built on Capacitor. There's not really another choice there. Am I right?
Yes.
So built on Capacitor so we could ship this to web and Android and iOS. Because yes, I have all of those devices in my house and I need all of them. Additionally, for the actual application itself, I chose to build this with Solid.js. So that's kind of my go-to framework of choice when I can get to choose. I really like it. It's very React-esque, but it has all of the little nooks and crannies figured out where React kind of will foot gun you if you're not careful. So really like Solid. So I picked that for my UI library and then built with Tailwind. I just wanted to get something that will go quick and easy. And then on top of Tailwind, I decided to pick up Daisy UI, which is a component library built on top of Tailwind, which I really, really like and highly recommend. So doing that. And then for all of the infrastructure work, I went with the most glorious and awesome Supabase. Big fan of Supabase. I've used it in several projects, and for this application, it was a perfect fit. I needed something with simple authentication. I don't necessarily need hosting, but so I needed something with simple authentication with edge functions that can run all of the code completions and kind of keep all of the tokens for OpenAI secure. And that's about it. I also take advantage of real time because it's cool to take advantage of real time, but not a hard requirement, but really like it for that.
Oh, nice. So why don't you go ahead and open up the project and we'll start diving into it. As Dallas is opening that up, if you like what you see, please be sure to like and subscribe to the channel. We're going to be having all sorts of different content relating to ChatGPT, interesting projects, how to do new and different things with Capacitor. We really appreciate it. And of course, be sure to check out the Ionic blog. The Ionic blog has a ton of great information like tutorials, product updates, announcements, and more. For more information, be sure to check out the Developers tab on ionic.io to view our docs and join our communities. We have an active community of Ionic developer experts on our forum and Discord that can help you through your Ionic journey and build the applications that you want to build. Our forum, docs, and Discord are great resources for any questions, comments, and feedback that you may have to supercharge your applications as you're building them. Links will be posted down below. Open. I think the audience can see Visual Studio's open. Why don't you tell us about your project and your code, and let's walk through it.
All right, yeah, let's jump in and take a look here. So we're in a VS Code workspace, and we're in this workspace because our application actually has two different parts. The main part is our project root, and that's all of our Capacitor application, everything that's going to run that application, all of our Supabase infrastructure, with the exception of our edge functions. So Supabase edge functions are built on top of Dino as opposed to Node, and so they have a slightly different tool set that you use. So VS Code has this nice little workspace so we can kind of separate those out as we work through them. So let's just kind of talk through the project about what this was. So the goals of this project really are pretty straightforward, right? I need some sort of user interface that replicates something pretty close to the ChatGPT interface, and I want to be able to have it in a mobile app. So that's basically the requirements here. So in terms of our pages that we're going to look at, we really only have 2 pages. We have our home page, which this is more of like an unauthenticated page where if you're not logged into the application, you'll be here. And then we have our chat page. So once you're logged in, here's the page we use to actually sit down and chat. So we can kind of talk about each of those different pages and what they are. So if we start here at the home page, we're using Supabase authentication, which is great because it has all of the different pieces kind of built in for us. So we don't need to do a whole lot of work there. What we're going to do, if we scroll down here, we can see our UI. We have our title. This is the self-titled Starfleet AI, which is kind of fun. So I'm not actually a Star Trek person. I didn't realize that Starfleet was from Star Trek, and everyone I've showed this to has been like, whoa, yeah, Star Trek, that's so cool. And I'm like, oh yeah, look at that. I didn't. Yeah, that was absolutely my intention.
So the entire Starfleet reference was a complete accident?
Yeah. So it's actually how I name all of my home Internet of Things. So my entire network is my Starfleet network, and all of the different, nodes on my network are different entities on that. So like my main computer that actually runs everything is called Star Commander, which I thought was just kind of fun. And this is now the AI tool that's going to run it all. So total accident, but it worked out. Worked out real fun. So this is our Starfleet AI application, and we just have a simple form here with our email and our password that we're going to use to log in. And that's about it. So we can see when we submit this form, all we're going to quickly do is jump up here to this on form submit. We're going to try our login. We make sure we have our email and password. If you're familiar with Solid.js, you'll recognize signals here, which are basically the better version of use state. Don't at me. Yeah. We have our email and password that we're pulling here. We're making sure we actually have valid values for those before we try to submit, and then we'll submit those to Supabase. And if we get an error, we'll pop up an error for the user. It'll probably say, you did something wrong, invalid credentials. Otherwise, if there's no error, we're successful, and we'll go ahead and navigate into our chat page. Pretty simple and straightforward as that. So once we get into our chat page, we kind of get into a little bit more of the complexities of the application. So there's a couple of different moving parts. And when we talk about how this application is designed, I think one of the best places to start is to kind of look at the data structure inside of Supabase. So we have our migration files for Supabase, and this is how we define our database. And this is really what we're going to drive all of the architecture of our pages and how everything kind of interconnects together. So everything is built on top of this single chat object, this chat table, right? It has an ID. It's linked to the user who owns it, so we can make sure only that user has access to it. We give each table, each chat a name so that we can, make that visually interesting for the user. They can recognize what chat they're in. We're going to enable row-level security. So if you've worked with Supabase and Postgres, you'll know that row-level security is a way to authenticate your users to ensure that they can only access the data they're supposed to. We have a couple of different rules here that we are implementing. So we want to make sure that only the owning user can read their own chats, right? If you're not the user on that table, you can't actually read the chat. Same thing. You can only insert chats for yourself. We don't want someone inserting a chat into someone else's thing. Definitely don't want that. And even more so, we don't want anyone deleting anyone else's chats.
Yeah, so, we want to make sure that this is completely secure, right?
Yes. Secured and locked down. And you also notice there's no way to, we haven't enabled any rules for updating. So with row level security, right, it's deny by default, and anything we want to allow, we have to explicitly allow. So once you've created this, there's no changing it. There's no going back. You're stuck.
Oh.
The last part here is we made a helper function that we'll use later, which is a way to identify if this user is part of this chat. And so this is just a database function that returns a Boolean true false. And we're basically just seeing, does the user have access to this chat? So we're looking for chat where the chat ID is based off what we pass in and that the user ID matches. If we get a record back, great, it exists. The user is in the chat. Otherwise not, we get false, the user's not in the chat, and we'll use that later when we're checking other rules. So that's kind of our top level chat structure, right? So this is what forms the backbone of this application, because we have different chats and everything is going to be related to an individual chat. So if we scroll down, we have our chat messages. So this is the next part of this. So whenever a user or the AI sends a message, we want to be able to save that in our database so it doesn't just disappear on us. So we create our chat message. Again, we have our ID, we link it to our chat, we're saving the message text and when it was created. We're also tracking who created this. So you'll notice this is by default created by humans. And this is a author type. This is an enum generated in our database just up here a little bit. If we scroll up to the top, author type can be human or AI. Those are your two choices. There are no in-betweens. And then again, we're also going to enable row-level security. We're also going to add this table to Supabase real-time. So the benefit of doing this, we'll kind of see later, is if we have multiple instances of this application open, say I've got it open on my desktop and I also have it open on my phone, the messages will stay in sync between those two different instances. And so when I send a message on web, it'll just automatically show up on my phone, which is great. So we're going to add that to the real-time. And then we're just going to tell Supabase we want the entire identity whenever that message is inserted or updated. And then again, we're going to write our policies here, right? So for chat messages, we want to make sure that the user who owns the message can read that. And the way we understand who owns that, because there's no user ID on this, we could put a user ID on this message, but then how do we, when the AI responds, does the user doesn't really own that message? That wasn't their thing. So that's where we get back to that user and chat function that we created, right? We make sure that anyone who is in this chat, which is just the user who created the chat, will have the ability to read all of the messages in that chat. And then same thing for insert. We make sure that the user is in the chat. And then we have one additional rule. We also say that a user can only add messages that are created by humans. So you can't jump in and say, oh, I'm going to type up a message and I'm going to send it as an AI because I am the most advanced AI there is. That's not possible either. So
nope.
This is, you have to be human, right? So that is a restriction we've put on inserting documents into this database, is you can only insert if the created by value is human. Then we create one additional little helper function here. This will just update the updated at time on the chat document whenever we add a new message to a corresponding chat. So that way we can go through and we can sort the chats by when they were last, when the most recent message came in. So we do that anytime we insert a message on chat message, we will execute this function here to go update that time on our chat. So that's our structure, right? That's really all that we need. So we have two tables, we have our chat and our chat messages. And with that, we're kind of ready to dive in and look at the actual application code a bit more.
Yeah, let's jump into it. Let's see what it looks like.
So if we look at our chat, the actual container itself is pretty straightforward. We have a quick check to make sure that we have a user. We also have this effect up here that if there is no user, it's going to throw an error that you have to be logged in, and it's going to kick you back to that home page. Right? We don't want, you have to be a user. Otherwise, you can't have any chats. You're not welcome here without being a user. Otherwise, our interface is pretty simple and straightforward. We have our chat header. We have our sidebar wrappers. This is what's going to give us our sidebar. We have our message space. We have our chat input bar. And that's about it, right? That's the entirety of our interface there. So let's take a look at the code. I think this would be a good time. We'll drop out of Zen mode and we'll see what the end result we are looking to get out of this is going to look like. Okay, so we have our chat interface here, right? So we can kind of see we have our history off to the side of all of our different chats we've been having with the AI, and we have our message box down here we can type into. It's currently disabled because we're not actually looking at a chat. We've got our title up here. So what this will look like is if we want to create a chat, we'll have this option and we'll say, this is Capacitor show. We're going to use GPT-4 for this. It's going to go ahead and create our chat. And now we can start talking to the AI. We can say, hello, AI. My name is Dallas, and I work for Ionic. Send that off. You can see we've got that nice little streaming back action. Look at that. And it all knows who I am. It wants to know how it can assist me. So we can, maybe ask another message and be like, how do I Center a div on a page. The most difficult of all questions.
Yes.
Right. And we get our nice little response back. And so it's going to, come in and do this. And there's a lot of functionality going on here that we'll kind of dive into throughout the remainder of this video here. One of the cool things about this, though, is this bot has memory, right? So if you've ever worked with the API, right, when you make a request, you'll get an answer back. If you make another request, there's no memory involved, right? But if we come back and we say, what was my name? And we ask it, it's going to come back and say, your name was Dallas. That's great. It remembers who I am. So this even has memory available to it as well. So it'll be able to, remember who I am, remember details of the conversation we've had. And so you'll be able to kind of get into that deep introspective conversations you'd have with ChatGPT, which is how I like to use ChatGPT. I like to, have these ongoing conversations and kind of use it to build out ideas. So this is what we're building out. So we can kind of see that structure in our code here. Look, there's my environment variables. Let's see. Yeah, so if we look at our chat. So if we come back to our code, we'll see that this is really the structure we have here in our code, right? We have our header, which displays our chat name. We have our sidebar, which contains all of our history. We have the message space, which is going to render out all of the messages. The input bar where we can type everything in. And that really is the entirety of our application. So if we look into our components folder, we can see there's a handful of components that build all of this up. We can kind of start from the smaller pieces, and then we'll talk about how they all work together at the end. So the different messages, if we look at those, are really straightforward, right? We have our AI message, which is going to take a structured document from our Supabase table that we created, our chat message, right? If we look at this message and everything that's entailed on it, right? We have our chat ID, the message text, who created it. And then we have all of this laid out. And you can see this is very Tailwind, right? It's built on Tailwind. So a lot of Tailwind classes you're probably familiar with, as well as a lot of the styling that's brought in from Daisy UI, which is great that all of this is, super simple to build out. There's not a lot of custom CSS in this application at all. So we just have our little chat bubble and we have our message text. We'd see that if we have an AI message that hasn't responded yet, we'll have an empty text and it will give us our nice little loading dots. So we can get that visual feedback that it's coming in. Our human message is a little bit simpler. We never have a human message without text. And so we can just display the text, and otherwise it's about the exact same. So those are our messages. We have our message space. So this is what contains all of our messages, which again is very simple. We just have our single container that, sets up all of the layouts here. And then we just loop through all of our messages that we have as part of this chat. And then we look, was this created by AI? If so, render out an AI message. If it was not, we'll render out a human message. And that's the basics of it. The only other complex part of this is that eventually, once we get enough conversation going on, so we pull this back over, and maybe we ask about thunderstorms, what is a thunderstorm? Oh, I can't type. Right? You'll notice that as this message will start to get up above the screen here, and in fact, we can speed this up by zooming in. This is automatically scrolling down for us as each new line comes in, right? We don't want to kind of lose all of our text below the fold as the bot is talking. We want to make sure that we see that as it comes in. So this code here handles that for us, where we come in and we say, okay, every time our messages signal changes. So this create effect is essentially the solid JS version of use effect with a little bit better ergonomics. And we say, based off of when messages changes, we want to scroll to the bottom. And if we look at our scroll to bottom function, all this is really doing is a whole bunch of logic about, should we actually scroll to the bottom? We want to make sure that the user hasn't scrolled all the way up to the top. Because one of the very worst things that can happen is you're reading something way up high and you get forced to the bottom of the page because a new message came in. It's super annoying. So we do a bunch of logic to just kind of check that. This is basic. I'm sure you could refine this and make it a lot more complex. But at the end of the day, we decide, should we scroll or not? And if so, we scroll our container to the bottom of the page.
That's a nice little slice of life thing right there. That's really nice.
Right. Yeah. Yeah. So you just kind of keep yourself at the bottom. If you've ever had to build a chat application, this is one of those things that can be really annoying if you don't get it right, and it'll drive your users crazy, because they're constantly not getting pulled down right, or they get lost in the messages, or something appears below it and you just don't know it was there. Yeah. So lots, this one little piece of code right here goes a long ways to user happiness. So yeah, that's our message space. This is everything that's rendering out all of our messages in the middle. If we look at our input bar, so this is specifically that text area at the bottom that we're using to send messages. We can see that when we send our message, we'll kind of look at this first because we do a couple of checks. We make sure we have a chat. We make sure that there's nothing currently in flight. If we're waiting for a response from the AI, we don't want to be sending multiple messages repeatedly or accidentally hit the send button 2 or 3 times. We'll do, again, just a quick check and make sure we have our chat, that there's a valid ID, and then we're going to structure a new message with all of the appropriate values. We're going to optimistically add this to the UI early. So something that if you're developing with a database, right, there's a lot of latency that can happen between the time you hit enter and it goes to the database, it saves it, it comes back, it says, okay, we're done. And this application, we've chosen to be very optimistic that all of our database writes will be successful, or at least the majority of them will be. And so I've gone through and added the message to the UI ahead of actually saving this so that we're not waiting on that latency, so that it's a faster perceived performance for the end user. And then what we've done is after we insert this just from Supabase, we actually grab our error document that will come back. And if there is an error, we'll display the error to the user, and then we'll go back and remove that again from the UI. Now, you might have some more complex behaviors, if you were building this out for anyone that wasn't myself, right? This is just for me. So it's okay if it just rips that message out of the UI. But, maybe you want to mark it as failed and give the option to resend and try again or something like that. But in this case, we've optimistically added it so that it will be there, hopefully. And then assuming all goes well, great. We had an instant response time instead of, the 200 to 300 to, even 2 or 3 seconds, 200 to 300 milliseconds or 2 to 3 seconds wait time from that round trip to actually go save the message to the database. Once that's done, if it was successful, we're going to clear out our input field. Doesn't need to be there anymore. And then we're going to send the user's message off for response. And basically what that means is we're going to send it off to the AI to go get a response. And we'll kind of look at how that works later. Other than that, if we look at the UI, again, very simple UI here, right? We have our container, we have our form with our text area inside of it, and our send button. That's about the effects of it. We have a couple of helper functions. Typically when you hit enter, you want to send a message. So this handles hitting enter, it'll send it. Unless you're holding the shift key, then you get a new line, right? So that's also some pretty common functionality in terms of your chat applications. So just kind of replicating that a little bit. So that's the majority of the chat functionality, right? Those 2 components. If we jump over into the sidebar, this one's a little bit more complex, but it's only complex for one reason, and that's the mobile behaviors. So we'll kind of get to that in a second. The chat sidebar wrapper here, right? You see there's a whole bunch of signals, a whole bunch of information. Realistically, all that we need here is our chat, so we know what's open. And then if we jump back down to the UI, again, this is more complex, but if you really look at it, a lot of this is, here's the toggle for the drawer. So by default, if we come back over here, on large screens, right, this chat history bar is static. It'll stay there. But if we pop open our dev tools and we scroll this down, that will collapse in on itself and become a drawer. It'll slide over the content, right? So that'll feel a little bit more mobile, because we do plan to deploy this both to web as well as to a mobile device. So we can see if we even shrink this down all the way to an iPhone 12, right? We get this nice little good looking drawer here that we can use to cycle through all of our different memory or our different chats. So a lot of what you're seeing here is just that UI for that. And if you're using something like Tailwind and Daisy UI, all of this is done for you. It's great.
That makes it a lot easier, right? Like you don't have to custom develop all of this user interface stuff.
Yeah, most of this is copy paste for the most part, right? I think the only thing I have is I forced the drawer open on large screens. And that's probably about the extent of my customizations to this, which is pretty great. All of this otherwise comes from Daisy UI. So we look at this. This is just our toggle, right? This is our main container where the rest of our application will live. We have our drawer. If we could look here, this is our create new chat button. And we loop through all of our available chats and create, elements for each of those and allow the user to click on those. And then we have our giant spacer, and then we have a logout button at the bottom. And that's the entirety of it. So while it's a little bit more complex, at the end of the day, it's actually pretty darn straightforward.